Hello guys, welcome back. Yes, we ran into a few pickles. Yes, the first two videos did not have any audio, or most of them. But let's get started right away. You guys can hear me now, because I fixed it. Okay? I think it's kind of funny actually. That took a while. Oh, there I am. Hi. But now you can actually hear me talk. We're going to do a grade gorilla, which is just paper 1 questions in physics. And while I'm doing that, I just want to tell you, I have my email. You guys can email me anytime. It is ibguru47@gmail.com. The reason it's 47 is because if you heard of the story of the 47th Ronin, they were warriors and they defended their master. And their master was killed or something. I don't know the story, but they fought back until they all died, and they were legendary people one day. They were super cool. You can search it up one day. And the video was an hour and 16 minutes. I provided a lot of context for myself. I'll try to re-put that in here. Let's start. Right. This is topic 4.4. The normal line is an important concept in the topic of refraction. Drawn at a point where the wave hits the refracting medium, which is just a description of the normal line. It's perpendicular to the surface. Yep. So B. No, not A. It's B. The angles of refraction should always be measured between angle is a refracted wave and the normal line, right? Yep. All right. See. A prism refracts light. Which of the following diagram correctly shows the relevant normal? Which of the following diagrams correctly shows the relevant normal lines and the light being reflected? What? Prism refracts light. Okay, refracts it. Which of the following diagrams correctly shows the relevant normal lines and the light being refracted in the correct direction? Oh, okay. So it wants to know if it's faster, it goes towards the normal, right? So if this is a fast medium, then slower, and then faster medium again. So I know it's definitely not that, and definitely not that, because they're not perpendicular to the normal. Yeah, they're not perpendicular to the yeah. So it's gotta be A or B. And it's not slower. Is it A or B? It's either A or B. I'm gonna go with the A for now because it's the same medium, so it makes sense to refract the same way. Right. A rope is tied and fastened to a pole, and 2 wave pulses are produced by moving end of the rope up and down. Right. The first pulse produces weak, the second is much stronger and higher amplitude is shown below. Pulses are reflected. Oh, I think it's going to be 1 up, 1 down. Which of the following diagram shows the reflected pulse correct? So if it's strong, then it's probably going to reflect it downwards. But this is going to speed up faster than it. So I'm going to guess B. Total internal reflection will only occur if a wave is incident on a surface such as glass under certain conditions. Which of these best describes these conditions? Oh no! My phone got blocked off. Pop blocker. Okay. The angle of incidence is greater than the critical angle. What was it? I forget what it was. The angle of incidence is it greater or less? Let me switch it up. What happens when oh no, okay. What happens when the angle of incidence is not equal? Surely it can't be equal. is greater. Greater. Then you get total internal reflection, right? Reflection. Yep. So yeah, the greater. So it gotta be greater. The ray is traveling, and the ray is traveling in glass towards the air. Let's see, it's in glass. It's not. Yeah. Which of these is the best description of the critical angle of a medium? The angle of incident ray is refracted. Which of these best described? Ray Skywalker. The angle of refracted ray when the incident is it 90 degrees? Is it normal? Is it parallel? Is it refracted ray or is it incident ray? I think it's refracted ray, but I'm not sure if it's the. It's gotta be the normal. Okay, water will refract light, but also refract sound. Table below gives typical values for the speed of sound and light in seawater. I got finished before 4 minutes, I think. So speed in sound, speed in seawater, speed in sound. Light and sound rays pass from air into water. An angle which is 10 degrees. Which of these answers in the table below gives refracted angles for the sound light? What? Pass from air to water, angle of incidence to 10 degrees. Which of the answers in the table below gives the refracted angles for sound and light? So the angle of refraction is less than 10 degrees. It's got to be. But the sound is greater. Yes, so B. Or something like that. I don't know, I might be just, full of crap. Is the refractive index air is equal to 0? What is refractive? It's N equals CV, right? C over V. Chemistry is so confusing. So, if the refractive index of air is equal to 1, what is the refractive index of seawater for the light wave? So, speed divided by the index. So, speed divided by 2.3 times 10 to the 8. So, it's either A or C. Oh, no, it's A for sure. What am I saying, man? It can't be 10 to the 8, man. Okay. Lighter rays on the glass blocking shown. Refractive index of air is 1 and 1.6 for the glass. The value of sine 30.5 is half. Sine 30 is half. As the light enters the glass and changes direction, some properties of the wave changes. Which is best described changes the wave properties? Frequency never changes, so eliminate A and C immediately. So stays constant. The speed of the wave, it's going slower. It's going into the water, so it's going to decrease. And then we got our answer D. The question. Which of these formulas is equal to the angle of incidence? Dude, I got it. Okay. Is this Snell law? So N1 over N2 equals sine theta 2 over sine theta 1, right? So which of these is equal to the angle of incidence? So air, 1.6 for the glass. So air 1 over 1.6 is equal to sine, so which is equal to half over, I'm going to run out of time, sine theta. This is what we're looking for. So, oh my god, it's paper 1 question. So it's going to be 1 over 1.6 divided by, it's going to be 8. It's gonna be A. I think. I hope. I hope. I got 30 seconds. So 1 over 1.6 divided by 0.5, which is like timing the reciprocal, so it'll be 1.6 over 0.5. So C. Bada bing, bada bong. Let's go. Oh, you guys can hear me now. Oh. Oh, submit. Come on. Oh, yeah, baby. Okay. It's gotta be it. It's gotta be it. That was terrible. Sorry you guys had to hear that. Yeah, 100%, 100%, 100%. Yeah. But there's some of you that are nerds. Like, you're an idiot. What are you doing? Why did you choose all the wrong answers? That's it. Oh my god, dude. Let's try to find the mistakes. What I do is write the question and the option I picked, and then the other option. Was it? No, it's not B. Then it's gotta be D. So what I do here, right? I'm gonna write question 4, right? I'm gonna write. I picked B already, and I picked D. So I'm gonna write that down. And then for question 6, I picked D. So then it's probably C. Because refracted rays. Refracted ray, I know that. Here, question, what is it, 7? Guess B. I didn't get that right. So is it flipped then? Is it this one is greater than that? So maybe C? Maybe? I don't really get this question. That like the angle of incidence is 10. That the angle of refraction is bigger, and then for sound it's smaller, something like that. I know it's bigger for sound. Is it not bigger for sound? I guess it's smaller for sound then. And then A, we did A. Oh, there's just no way, dude. Then there's gotta be B, because that's the only one that tends to be 8. And then we did 9 correctly, and 10 was wrong. We chose C, and I thought as well that A could have been an option. So I'm guessing I may get a few more wrong here, but most of them should be right. Now, 70. So you go back and you look at the ones you got right from there, and you eliminate them, and you look at the ones that is still marked wrong, and that limits down your options again. So 6, so 4 I got it right. 6D, we guess D and C. So it's got to be the incident ray. I'm guessing B because I know it's not 90 now. So I'm gonna guess B. We eliminated 7. 7 was correct. So 7, right. C. So if it goes to the angle of incidence, in sound it's slower, and in light it's faster. Right? This is not B, A or B. Interesting. So maybe it's D, because we had that initially. The fraction was correct. Is that question 8? D. And then which of these formulas is equivalent? We guess A and C. So let's try our luck with, well, I guess all of them, man. Maybe it's C. Is it sine inverse? It's not sine inverse. It's just, oh, we get C. So it is sine inverse. So it's B. Is it B? I have no idea. Look at my pen spinning. Look at my pen spinning. Good luck, huh? It's wishing me luck. Look at it. I seriously get one of them wrong, man. Gotta go back and check them. I got 3 wrong in the last one. 6 is still wrong. Get DCB, so then it's gotta be A. That's what happens. So we know the answer now. The best description of critical angle of a medium, the angle incident ray when the refracted ray is, Oh my God, it's in my definition sheet. I'm so dumb. Okay, take that out. Dude, it's C? What? And that was it. And we got number 10 right. Oh no. Okay. Awesome. Fantastic. Fantastic. Now these are the easy questions. Wait until we get to the Kognity questions, man. These are hell. Okay, let's do the Kognity questions. Let's do all the paper 2 questions first, then we go back to the paper 1 questions in the Kognity. Because I prefer that. And then I don't know. I think we done enough for the day today from the couples videos that Pew 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 pew. All right, Cognitive, show me what you got. These are mostly calculator questions. So we got the upper hand here. You guys can see like phase. You can see it phase, man. You can see the phase thing. You can see it phase. It's phase, man. That's okay though. That's okay. This should be 30 minutes tops. That's a lie. This could be an hour. That's okay. I haven't been talking much about myself in this one. We've been focusing. What can I say? We've been focusing. I hope you guys like my thumbnails, by the way. I thought they were pretty interesting. And I put the PDF books for the 8 questions only. I put the PDF books for the EE just in case you guys want them in my links. And I don't know if I can send you Kognity. Yeah, you need money. You need like pay for it. But I'm gonna link it anyway, because why not? Okay. So that's paper 1 question. Oh, there we go. Let's do paper 2. Blue light, 400 nanometers in the air, decreases in wavelength by 130 when passing from air to water. If green light has a wavelength of 510 in air, what's the wavelength to the nearest millimeter in water? Oh my God. How do you know how much it decreases by? Right, so it'd be topic, so C equals frequency times lambda. So lambda is speed divided by the frequency, right? And we can use our data booklet for this one. So lambda is speed divided by frequency. So if lambda is 400 here, nanometers, then C has gotta be, what is, so, speed of air, speed of blue light in air. And then one of them is decreases in wavelength by 100 from passing air to water. So it gets slower, obviously, we know that. I'm just writing 510 equals. How to calculate, I'll just search this up, how to calculate wavelength from two mediums, right? Oh, my ears, dude. They hurt so much. These headphones are so bad. Okay. Choose the velocity of the wave. No, I don't want a wavelength calculator. Yeah, right. We got that far, and the wavelength zero can cancel because the frequency does not change. Yes, yes. So the wavelengths cancel. So it'll be 400 equals 3 times 10 to the 8. Speed of light in water. Speed of light in water. Uh, um, uh, 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 2.3 times 10 to the 8. Is it? No, bro, I'm looking at the wrong things. I don't get this question. Come back to it later, maybe? Maybe. Let's do it. Okay, how many paper 2 questions are there? A lot. Paper 2 questions. A lot. A lot. No. Misha's sad. So just, yeah, better off solve it. Let's do the paper 1 questions, actually. So light is moving through glass at an angle of 4 degrees to the surface. Which of the ray Skywalker diagrams best represent the ray before and after the light has reached the surface? Could that happen? Total internal reflection. Could it happen? Could it happen? Could it happen? Yes, right here. I'm gonna guess total internal reflection is gonna happen. Could be wrong, but which of the following characteristics change upon reflection? Does the wave speed change upon reflection? I'm not sure. Does the speed does it change upon reflection? Maybe. I don't know. Could change upon reflection. Definitely. Does wave speed change upon reflection? I know it's not frequency. Frequency doesn't change. Could change upon reflection. I'm gonna guess number 3 because I think I saw it before in one of the answers to the Kognity Questions. I think. Could be 2 or 3. Alright, let's go back to this one. So 400 is the z over f 3 times 10 to the 8. And 510 is also 3 times 10 to the 8. Then you divide both of them by 3 times 10 to the 8, and it just says like it decreases by whatever. So 400. Let's just do this. Right? 400 divided by 3 times 10 to the power of 8. Okay. That weird number. Oh, it's 400 nanometers. What did I just find out, boys? There's a unit conversion. And I almost missed it because I'm a total retard. Okay. It's been helpful for you guys, too. I mean, You probably don't know that there's Unicode. Actually, you probably do know. You guys don't know. Me too, but yeah, whatever. Okay, nano. 400 times 10 to the negative 9. Wow. No, times 10 to the 9, period. Over 3 times 10 to the 8. It's going to be 4,000 over 3. This is multiplication though, which is math, decimal, 133.333333333 plus 130 times 10 to the 8. Well, no, I don't think that's right. I can't be right now. What if it's 4 times 10 to the negative 9? That'd be interesting, wouldn't it? I'm not sure what to do. Man, this thing keeps going up. Man, I just freaking terrible, man. Whatever. Times 10 to the negative 9 over 3 times 10 to the 8. That weird number is a number. That's the correct answer. Dude, why do people keep calling my brother's phone number? Man, like, stop, I'm doing physics. So, I'm guessing that's the right number? It'd be 130 nanometers around? The final term, the bottom line. I think that's it. That sounds right. Right? Point 7 times 10 to the 9. 1.7. What's the answer for this? Didn't want to give it? Okay. Dude. Power negative. Sorry, yeah. Just gonna get this. He's gonna spam him now. He's gonna spam him, I swear. That's what all them teenagers do. They just spam them. Right. If travels at 20 meters per second and strikes the boundary in the medium. Hold on, let me just gotta draw this, okay? I'm very good at art and physics. Right, so wave, so we draw the boundaries here. Wave travels 20 meters, strikes the boundary to a new medium at angle 28 degrees to the normal. New medium, the wave is directed to make an angle 32 degrees to normal. This is wave speed new medium. What? I know exactly what to do. I just gonna use Snell's law. Am I gonna do that? Yeah, it tells me that a wave traveling 20 meters per second, the first one is gonna stall for one of the V. My God, I'm genius. People love my actions. I'm telling you. People love my actions. So, right. Oh, it's going to bend away from the normal. So it's 32 degrees and 28 degrees here. And then we don't know what. There it is, guys. There it is. That's my diagram. That's my diagram right there. You guys see it? Gotta put my headphones in. Alright. Now, I promised I would help you guys. So, what we're going to do here, the one wave is traveling like this, 20 meters per second. And it hits the boundary, draw a boundary, draw the normal to the line. So, let me draw a better example. So, just draw a boundary and the normal to the line. Boom, like that. Oh, okay, you guys can see it. Right here. Okay? Draw a boundary and normal to the line first. Then get that first wave in. It's coming in at 20 meters per second, so you're at 20 meters per second. And it gets refracted, making an angle 32 degrees. So once it bends away from the normal, right? So, right here. Got that so far. It goes in, it bends away from the normal because it's a bigger angle. It's coming at 20 meters per second. Now all you got to do is fill in the angle. So 28 degrees, and here it's 32 degrees. See that? Boom. And that's then you use Snell's law, which is, we're not going to use the refractive index, right? Because it's N1 over N2 is equal to sine theta 2 over tan theta 1 is equal to V2 over V1. We're going to ignore the N1 over N2. We're going to use V2 over V1 equals sine theta 2 over sine theta 1. Why? Well, we have sine theta 2, we have sine theta 1. And we have V1, which is 20 meters per second. We don't have V2. And that's what it's asking for, V2. So what we're going to do is we're going to do sine theta of 32 in degrees, sine over sine theta of 28 equals V2 over 20. Awesome. So let's do it. Sine, it's in radians, Remember to change your calculator to degrees when you're not doing math. Sine 32, right? And then sine 28, that number divided by that number, is going to get you that number. So it's going to be V2 over 20 is equal to 1.128, yeah, blah, 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 blah. So you're going to multiply that by 20, and you're going to get the angle. There's 22.575. So what's it say? 266? 22.266. Isn't that 266? 22.6. Technically it's 23, but I want to be sure about it. Okay. Ray enters the glass from air. That's good. Let's draw a new diagram. So let's draw the boundary, draw the normal. So it enters from glass. Enters glass from air, yeah. Makes the angle of 40 degrees. Draw the angle of 40 degrees. With respect to the normal in air, and 36 degrees with respect to the normal in the glass. What is the refractive index of the glass? Another Snell's law question, but this time we're going to ignore the V and we're going to use the N, right? So it's N1 over N2. N2 is sine theta 2 over sine theta 1. Right, so how we do this? We have both angles. Sine theta 2 is 36, so sine theta 36 over sine theta 40 is equal to air. We know the refractive index is 1, so it's going to be 1 over N2. Right? So let's just get the angles first, and then we'll figure out the math later. So sine 36 and sine 40. So 36, the sine 36 divided by this, so like big weird number, and we're gonna get 0.914. So 1 over N2 is equal to 0.91 yada 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 yada. Do we divide that by 1? Oh, I'm not sure. Because it's 1 over that. It's 1 over N2. So we can do is we can bring the N multiplied to this side and then divide that. So it's 1 divided by this bad boy right here. That should be our answer. So it's 1.09. 1.0, which makes a lot more sense than 0.91. What? Oh, hold on. I'm searching up refractive index just to make sure. Look, is it faster or slower? That's the thing. Oh my god, it already knows what I'm searching. Well, I'm searching up refractive index. Numbers. Is it 0.91, man? Is it 0? It's 0.91. Oh, there it is. Water. So yeah, that means slower, right? I'm guessing slower. So 1.09 works. 1.09 is the one we're looking for. It can't be less than 1. Yes. We are right. 1.09. 1.09. Awesome. That was my channel. Haha. Oh, you guys didn't even see it. Excellent. Stand up. A piece of glass is an index of refraction. Speed of light in glass is blah 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 blah. What is the value of x? So glass, the refractive index for it. So n over CV, right? C over V, and we know that it's 1.65, and you know it's something times 10 to the 8. Well, we don't know what the number on top is. Or that number, dude. What are we supposed to... So, technically we're missing 2 numbers and we only have 1. I obviously know it's times 10 to the 8. So we're missing 2 numbers. Speed of light. Does it tell you anything in the data booklet about the speed of light in glass? Like the V. Isn't that what we're looking for? Never mind. We need a constant. What is a constant? The speed? Something meters per second? No, I got it. So 1 equals something over 3 times 10 to the 8. So that means that the speed is 3 times 10 to the 8 on top as well, right? Then we just do it for air. So it's Snell. It's my man Snell, right? Except it's N1 over N2 is V2 over V1. Bingo. Yes it is. Okay. So N1, we know it's air over 1.65 is equal to, well, V2 we don't know it, but we know 3 times 10 to the 8 is on the bottom. We put x here. We cross multiply. So it becomes 3 times 10 to the 8 is equal to 1.65x. And we divide, so 3 times 10 to the 8 divided by 1.65. So is 3 times 10 to the 8 divided by 1.65. There's going to be 181818181818181, and we're going to multiply it by 10 to the negative 8, right? What's going to be 1.81, 1.82 times 10 to the negative 8. 1.82. Gotta copy this part because I don't know how to do it in the thing. Dude! Just, okay. Suppose a piece, a special piece, suppose a special kind of glass has a refractive index which decreases from 2.4 to 2 when heated above 50 degrees. How much does the critical angle of the glass increase when heated? What? Skip. A laser beam. Oh, this one's an easy one. Laser beam passes from air to prism. The refractive index 1.5 and thickness 10 centimeters. The angle between the laser beam and the normal plane is 30 degrees. The laser beam comes out opposite side of the prism as shown is red. Okay. The perpendicular distance between the digital path of the laser beam and its final path. You need 3 numbers and you'll calculate that. Right. So the last 2 questions are not nice. 10 centimeters is 0.1 meters. And what's the displacement? How am I supposed to get that again? What's the distance between here and here? And I can even calculate this and that. So how am I supposed to get that number? We'll give it our best shot. And then we'll go back to the number 7. Let's check something first. While we're thinking about it. Paper 2, end of term. Okay. These shouldn't be too long either. I guess I'll do the reflection on my own, guys, because we're gonna be watching videos together anyways. I gotta be listening. But yeah, I'll leave you to it after I finish the Kognity assignment. But that's not what we're doing now. That's not what we're doing. We're trying to solve this one. Oh, I got it. Laser beam passes from air into a prism, so it's 1 over 1.5. And thickness is 10 centimeters, angle 30 degrees. So it's 1 over 1.5 is, what is it, sine theta 2 or sine theta? So sine theta 2, so it's going to be sine 30 over sine theta, which is what we're looking for. And then we'll worry about the thickness later. Let's just get sine theta so we have all of our information. So sine 30 is half, right? Yeah, it's half. And then 1 divided by 1.5, 2. So 2 equals 0.5 divided by sine theta. So I'm kind of lazy, so I'm just going to use numeric solver because why not? 2 equals, and then 3.5 over sine of x. It'd be 14.4. So 14.47. Looks like a pretty small angle. That's the angle right here, right? 0.47. That's the small angle here. And then the big angle here is 30. Yeah. And then get the displacement. I know, so 10 centimeters, 0.1 meters. Oh, I got it. I got the equation. My bad. It's S equals lambda d over d. Lambda d over d. Where S is the fringe spacing, what we're looking for. And then so wavelength times the slit space. So slit spacing. What's the slit spacing? And thickness. This is to screen. The slit spacing is 0.1 meters. What is the distance to screen? Do we even have the lambda? We don't even have the lambda, dude. Okay. Um, yeah, I have no idea. I have no idea whatsoever. Let's try. Free space is it double slit diffraction? It's gotta be double slit diffraction. Angle of incidence between the laser beam. Okay. So we got the refractive index for both of them, and whatever I do, I need the lambda. Distance from screen, I'm guessing, is the distance between here and here, right? And the thickness is the diffraction slit, so 10 centimeters. So it's S equals lambda D over 0.1. How else are we gonna find D? How else are we gonna find D? It's asking for S, and I can barely find one. So we got a lot further. So 0.1, and then lambda. We got. Can we get the speed from that? Oh my god, I'm genius. So since n is c over v, we can get the speed, and then we can get it from the v and the n. So let's do it for the first one. So 1 equals c over v. What was my idea? I just forgot it. Yeah, use the rule thing to get both speeds. Not sure that's a good idea though. That's not gonna work. So v2 sine 30, which is half, v2 half is equal to 14.47 v1. But I have no idea how we're gonna. This is not gonna do anything. Still can't find it. Any hints in this? Can you text this guy? Hi, man. You know, people don't call me L. Yeah, they can't even tell that message. Hi, L. We'll be back online tomorrow. Can't wait that long. Are you guys crazy? I'm gonna check critical angle increase and decrease data unit. So, if it decreases by 0.4 here, then I don't know, man. I don't know for any of these two. How to find, let's search up. How to find critical angle using refractive index. How to find critical angle from refractive index. There we go. Critical angle can be got by taking the inverse sine of the indices of the. Oh, really? So I take the inverse sine of 2 over 2.4. The inverse sine of 2 over 2.4. Okay, I think I got it. 2 over 2.4. No, it's 2.4, a sine inverse of 2.4 over 2. So second quit. Second sine inverse of 2.4 divided by 2. What domain? Then it can't be that. It has to be 2.4, and then up here is 2. 56.44. So it goes from, so 6.44. Right, decreases by 6.44. That's temperature. But isn't that the same thing? Because it's like lasers and stuff. I'm going to do 6.44. Because this number is pretty close. Okay? This one is a bummer, man. It's a pain. 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 I can't seem to solve this at all whatsoever. And there's no luck in finding the equation. I had to find S using the refractive index to find S using I don't know how to solve these questions, man. Refractive is only just the ratio of the speed of light in the vacuum to the speed of light to the medium. What you need to do is divide the speed of light by the refracted into the medium to find the speed of light through the particular medium. Oh, but that's smart. That's not doesn't give you the answer. But if I do, so if n is c over v, then n is, so 1 is c over 3 times 10 to the, right? It's just 3 times 10 to the 8, whatever, man. It's 1 over. So v equals 3 times 10 to the 8. We got that far, okay? We get that number. Now, c is 3 times 10 to the 8 as well. So 3 times 10 to the 8 is equal to, frequencies cross out in lambda. Now, what am I supposed to do here, man? So is the lambda also 3 times 10 to the 8? No. It's 1 over that because the frequency, right? I sound like I'm full of bollocks right now. Maybe I'm not. How do you find distance from screen? Oh my. Oh, that's my mom calling. Oh, she might walk in here soon. Gotta be. I'm gonna put 14.47 because that sounded right. No, what am I saying? It's like 3 point something. 1.3. Sorry guys, I do not know how to solve this, and don't know I'm gonna go anywhere near this solving it. Let's check out our luck. 0%. Oh my god. Okay, I got the first one right. Get the second one right. 144 nanometers. Okay, let's check out what we did wrong here. I got the last one right, didn't I? No. Okay, well, let's see what he did. So N1, N2, oh my god, I forgot about this one. So N1, N2, so I get 270. I get 207. What? How do you get 270? That's my question. Where do you get the 270 from? Oh, 400 minus 130 is 270. So 270, so lambda 2 over lambda 1 refractive angle. So you got that over that, right? It means lambda 2 can be lambda 1 times yeah. I get it now. See? This is the following. Oh my god. None of them changes direction. Are you kidding me? This is full of garbo, man. I got the answer right. I did the same method. I got it right. Yeah, it was. I told you that in the beginning, guys. Oh, let's go, dude. We got that one right. Okay. What? Hi. Okay, just a second. What? Oh, no way, dude. Without the 10 to the 8. Oh, because it's just X. So it's technically got a lot more than I should give myself more credit. Whoa, no, dude. Okay. Memorize as it is not a double clip. Sine C. Let me write this down. Sine theta of the critical angle is 1 over n. The critical angles are sine inverse 1 over 2, 1 here, and sine 4, and just write 266. We'll give me 2. But here. Oh no, exactly what he did here. Okay. Let's read this together very slowly, guys. To solve this problem, you have to relate the thickness of the prism and the angle of the entry to the perpendicular distance. Okay, yeah. With S is lambda d over d. Laser beam is refracted going into it, coming out of the prism. You can use Snell's law to find the angles for the laser beam. I did. Given that you have distances and angles, it is best to draw triangles inside the prism. This will help you solve the problem. What? You can draw two angles and shown below. My god, dude. Is that what he meant by the 10 centimeters? Yeah, that's it. Oh my god, dude. No way. No. Oh. What is this symbol? For the lower triangle, you can use Snell's law, which you can get the hypotenuse, okay? Which is shared between two right angles, you know the h, and the angle, you can get the distance s, which is perpendicular distance between the two paths. Oh, duh. So, he finds that it's 19, I got 14.47, I don't know how. Okay? And then that plus that, and that is 10 to the 4th feet. And that. Okay. I sort of get it. Maybe. Well, I might do more video today. One more video. I'm not sure. Maybe business or something. But thank you guys so much for watching. Have a good day. See you in the next one.